Hello, my name is Saul Franz and I'm a platform engineering consultant at Ensono Digital. In this video, I'm going to be talking you through our .NET projects and deploying them to AWS using a GitHub Actions pipeline. So over on the Ensono Stacks website, you can find more information about Stacks projects. I'm going to select the language we're going to be using, which is .NET. We'll be looking at the REST API with CQRS and deploying to AWS. So here, this will take you to the page where you can find out more information about the project itself, how to install it, how to create it and run it locally. But what we're more interested in this video is the infrastructure and the pipeline. On the infrastructure page, you will find a diagram of some of the infrastructure provisioned, as well as a list of resources, a description, and the available pipelines you can use to deploy it. Currently, only GitHub Actions is supported for AWS. On the pipeline page, you can find sequence diagrams for everything the pipelines will do, from feature branch to dev environment and from main branch into production environment. You will then also find some instructions on setting up GitHub Actions, what variables need to be set, what secrets, and the instructions for just creating the pipeline itself. I'm going to be using the Stacks CLI to generate the project. You can find more information about this on the Ensono Stacks website, as well as instructions on how to install it on your machine. So over in my IDE, I'm going to now use the Stacks CLI interactive command. This will prompt me for some information about the project I want to generate. So for the company, I'll go with the name demo. For the scope, I will go with menu. We're going to be creating a menu API. So the component I will call API. We want to select GitHub Actions, AWS for deployment, and then it'll prompt us for some information about our Terraform state. We use Terraform to provision all of our infrastructure for the project, and for AWS deployments, we assume an S3 bucket will be used for storing Terraform state. Next, we need to supply the external domain as well as the internal domain. This isn't going to be a dry run. We're going to use the current directory and we're going to generate one project, which I will just name project. In this demonstration, I'm going to assume that the core infrastructure has already been provisioned. This can be generated with the infra option, and this will create the VPC as well as EKS and any other resources required. But in this example, we're just going to select the .NET, and it's a CQRS framework. No additional properties. This question is not applicable to AWS. We'll use the latest version. Select GitHub as our source control, and now I will get the URL for our repository. So I've got an empty repository here, which I'll use. The cloud region, we'll use EU West 2. And for the group, I'll go with demo. So that has now generated a Stacks YAML file, which when we look at, basically just contains all the answers that were provided to the interactive command. And the output also gives you a scaffold command, which I'm going to copy and paste to run now. And this will generate all the files required. And that's it. We now have a project directory with all the files we need for this build. In the .github directory, we have our workflows. Here you will find a CI YAML. This contains all the jobs that will be run by the pipeline. So we've got a build, app infra dev, deploy dev, and then the same jobs repeated for production. The workflows also contain an environment file. Most of these will be populated with values that you've provided to the interactive command. These files will need to be updated and we'll come back to them later. In the build directory, you can find a GitHub AWS folder, and this just contains a README pointing to where the workflow files can be found. There are also some template files which we use to install taskctl. Taskctl is a service we use to run tasks in a consistent way across multiple environments. So there's a taskctl folder with a context for the environments, as well as a task list which is basically everything we use for running in the pipeline. You can see tasks for pulling container images, updating build numbers, linting. You'll also find testing, build, etc. And these are all run within containers, so you can run these commands in the exact same way in your local environment via taskctl as we are doing in the pipeline. The final file within the build directory is a deployment list, and this just updates some placeholder files within our Helm charts. In the deploy directory, you will find under AWS all the Terraform used to provision the infrastructure for this project. We use Helm for deploying the applications to the Kubernetes cluster, and in the values file, you will find the placeholders I mentioned earlier. These will be updated with outputs from Terraform as well as environment variables in the pipeline. In the templates directory, you'll find the resources themselves, which will be created within your Kubernetes cluster. There are some scripts which are used by the pipeline, and that's everything in the deploy. In the SRC folder, we have the actual application code itself. So if you want to look into this and update it, you can do so here. And then finally at the root, we have a Stacks CLI YAML, which is used by the Stacks CLI as part of generating the project. We have a taskctl YAML, which contains taskctl pipelines. These allow us to combine tasks into a single job. So here we've got lint, which combines the lint YAML, lint Terraform format, and lint Terraform validate. So instead of having to run all the commands in the pipeline, we can just run taskctl lint, and that will run all the tasks in the pipeline. The depends on job allows us to run things sequentially rather than in parallel. And then the final file is the YAML lint configuration. So now that our project's generated, I can go back to the Stacks documentation and find out the steps for configuring GitHub Actions. On the pipeline page towards the bottom, we can see we need to go back and update our workflow files. So I'll check these now. In the M file, most of these values look correct, but we do need to update our Ensono project name. Everything looks correct in that file now, so the next job is just to check the CI YAML, which I'll quickly go through and make sure everything is correct. Okay, so I've now updated both files for my environment, and I'm going to go back to the documentation to look at the next steps. We can see I need to set some secrets for talking to AWS. So over in our repository, I'll go to the Settings tab. And from here, I'll go to the environments, and we need a non-prod and prod environment. I've already set these up ahead of time, so you will need to create these and add the secrets that are specified in the documentation. You can see the environment secrets I have already set up, and these will allow us to talk to AWS and also provide information about where Terraform state is stored, as well as a Sonar token for our Sonar Cloud scan. We can see on the Actions tab that there's no current pipeline, and over in the code, there's nothing on the master branch currently. So I will go back to my IDE, and we will get this stuff pushed up to a branch. I'll first change directory into the new project one, and we can see there's already been a git init. And if I check the remote, we should see that it matches the URL I provided during the Stacks interactive command. So now I'm going to check out a new branch called Feature Generate Project. I'm going to add all of our new files, set an initial commit message, and push our new branch to the repository. Now when we go to the repository, we can see it gives me an option to compare and raise a pull request. I'm going to do that and just leave the title and description the same. So now that I've raised a pull request, because the workflow files are in the .github directory, it will already identify that there's a pipeline it needs to create, and it will start running it because we have a pull request trigger on a pull request to master. Over on the Actions tab, we can see this is already running. And now we can see the stages we defined in our workflow. We've got a build, app infra dev, followed by deploy dev, and then we've also got app infra prod and deploy prod for the production flow. We can click the build to look into more details what's actually happening. And here we can see it's currently pulling the images for task.etl to run, and then all subsequent task.etl tasks will use these container images. After that, we can see it's going to do some linting as well as testing, build the container images. It will build the functional tests, which we basically publish to the pipeline so we can reuse in a later stage after deployment. And then finally, it will generate the test reports and publish them to the pipeline. This is going to take a little bit of time, so I'll fast forward through this bit now. Okay, so now the build is finished successfully, and we can also see that the unit tests have been published to the pipeline here. You can click this and find out more details, and if any failed, this will also show here. The app infra dev job has already kicked off, so we can click on that and find out some more details. And very similarly, it's going to pull the task.etl images, and then this one's going to run the task.etl infrastructure task, which will plan and apply the infrastructure changes. Okay, so the infra job was completed, and we can see that 4 resources were added, and we can also see outputs for the different resources. So DynamoDB, SQS, SNS. And the deploy dev job has started. Again, this is going to pull the task.etl images and then run the deploy tasks via Helm, and then finally run functional tests to test that everything's working as expected. So now the deploy dev job is complete, and we can see the functional test report has also been published to the job. So we can see all of these have passed, which means we have a deployed application as well as passing functional tests. Over in AWS, if we refresh the list of DynamoDB tables, we can see a new one has been created. For SQS, we can also see a new queue has been created. And on the SNS topics, we can refresh the page and see that there is a new SNS topic. Finally, we can go to the URL for our application's ingress, and we should get a Swagger page, which we do, and that looks great. So that's it for this video. If you would like any more information on Stacks, please visit the Ensono Stacks website, and thank you for watching.